So keep in mind that once a statement is true in math, it is going to be true forever. So once you've proven something, it is true forever, and you can use the result to prove more theorems and propositions. So for instance, in the last video, we showed that square root of 2 is irrational. I can take advantage of that to prove that 1 plus 5 square root of 2 is irrational without having to do so much work like I did in the last problem. This is a good strategy and it's a good tip to know, and let me demonstrate what I mean by that. So in this case, we're going to do a proof by contradiction. Again, since this is not an if-then statement, it is not a conditional. So in order to do a proof by contradiction here, I'm going to start by supposing not. In other terms, I'm going to suppose that the 1 plus 5 radical 2 is in fact irrational for the sake of contradiction. So my goal is to derive a contradiction from this, which will convince me that 1 plus 5 radical 2 is in fact irrational. But let's run with this. Let's see what happens once we assume that 1 plus 5 radical 2 is rational. Well, because it's rational, we can use the definition of rational to find integers a and b, where b is not equal to 0, such that 1 plus 5 radical 2 is equal to a over b. Remember, we're assuming it's rational, so this is perfectly legit. We can pretend that it's a fraction a over b. But now we can start rearranging the terms in the fraction and isolating the radical 2. So first I can take out the 1 by subtracting 1 from both sides. Then I can combine the a over b minus 1 together into one fraction by using common denominators. And finally, I could divide both sides by 5 to end up with a minus b divided by 5b, and that's equal to the square root of 2. Now, a and b are both integers, so a minus b is going to stay an integer by closure of integers under subtraction. 5 and b are both integers, so the product of them is going to be also an integer. And not only that, but b is not 0, and 5 obviously is 5, which is not 0. So this means that this product is not equal to 0 either. So this is now saying that the square root of 2 is a ratio of an integer on the numerator and non-zero integer on the denominator, which means that square root of 2 is suddenly rational. But wait a second, that is a complete contradiction with the previous fact that we proved that square root of 2 is irrational. So that tells us that our assumption that 1 plus 5 radical 2 is rational must be false because it's leading to a contradiction, which means that the original statement that the problem had must be true.